VLSos here. This is a video lesson on solving equations. Lots can be said about solving equations. This is intended to be a reminder of how to solve basic equations that you'd find and become an expert at, hopefully, at about the middle of Algebra 1. So we have some guides. What it means to solve for is to get a variable you are solving for alone and positive on one side. An equation has two sides, to the left and to the right of the equal sign. So what we want to do when we solve for a variable is that variable we want in the end to be on one side of the equation alone and positive, and everything else that doesn't contain the variable on the other side. Let's see an example of a problem that we could start with. -2 times x plus 4. The x plus 4 is in parentheses. We're also adding a 6 is equal to 10. This is an equation because there's an equal sign involved that relates two sides, two quantities. We have a single variable x in this equation. Something typical given this math would be the instruction solve for x. If we're going to solve for x, we need to undo what's being done to x on this side. 4 is being added to x. We're multiplying by a -2, and then we're also adding a 6. So how do we get x by itself? We follow, in quotes, two guidelines for algebra. The first is to undo an operation, do the inverse of what you see. So if I wanted to get x by itself, I'm going to undo these three operations. And it doesn't matter which I do first. I could do anything I wish, but there are certain steps that are more helpful than others. I could subtract 6 from both sides. I see that I'm adding 6 to this side, so the inverse of addition, or the addition of 6, is subtraction of 6. So I would choose to subtract 6 from the entirety of both sides. I could also immediately undo this multiplication by -2. It's an uncommon choice to make, but it's not wrong to attempt to undo this -2 multiplication right away. I'm going to make that choice. I'm going to divide this side by -2. Now, the second guideline for algebra is in a quote here. What you do to one side, you must do to the entirety of both sides. So if I'm going to choose to divide by -2 to undo this multiplication by -2, then I have to remember to do that to the entire side and on the other side as well. This will help remind us that when we cancel out the multiplication by -2 with the division by -2, that this -2 is also dividing this 6. Canceling them out here does not allow me to just keep what's left. This -2 has to divide this 6 as well. So I'm going to write what is left. After I divide both sides by -2, I have the x plus 4, and I'm not adding 6. I need to add what 6 is after it's divided by -2, which is -3. Or -3. And that's equal to the other side, 10 divided by -2. 10 divided by 2 is 5. A positive divided by a negative makes it a -5. It might have been easier to subtract 6 from both sides as our first step, but we understand why this here can help us take any step we wish as long as we do it correctly. To get x by itself, I have to undo the addition of 4 and the subtraction of 3. I could also drop the parentheses and combine these terms. If I do that, well, I'm going to drop the parentheses. It's not going to change the addition of 4 and subtraction of 3. I'll simply have x plus 4 minus 3, still equal to -5. But I can combine these now to be an x plus 1. I have one more step to get x by itself and positive. I need to undo the addition of 1 with the inverse. I'm going to subtract 1 from the entirety of both sides. When I do, these will cancel out, leaving x by itself, and it's positive. a negative 4, I miswrote that. This was still a negative 5 in this step, and now I'm subtracting one more to make it a negative 6. It's a good idea to circle a final answer when you have a lot of work showing. Negative 6 is the solution to this equation. And if I found the solution correctly, it means that I can substitute this value in for x into the original equation and confirm that this is true, that the sides are equal to each other. So a check step would be to take the solution, substitute it in to the original equation, and see if this equation remains true. Is it true that negative 6 plus 4, which is negative 2, and then multiplied by negative 2, which would make it negative 2 times negative 2 is a positive 4, and then a 4 plus 6 makes it true that 10 is equal to 10. I've confirmed that x is equal to negative 6 is the solution to the original equation. Let's have another example. I'm going to start with an equation that has two variables. I could solve for either one. The instruction could be solve for x or solve for y, but I need to make a choice. I'm going to solve this equation for y, which means that I want to get y alone and positive on one side. I'm going to begin by getting rid of this 6x term on this side. I see that we have a positive 6x term, so the inverse is subtracting 6x. When I do that to the entirety of both sides, these will cancel out, leaving the 2y. On the other side, 10 minus 6x will not combine. Those are unlike terms, so I can simply show it as 10 minus 6x. I want to get y by itself. I have one more thing to do. I see that y is being multiplied by 2. The inverse of multiplication is division. I'm going to divide the entirety of both sides by 2. When I do, this will cancel out, leaving y by itself, and y is positive. This 2 is going to divide both these terms. So I can't just divide the 10 by 2 and get 5. Just like in the problem above here, we want to be careful. This 2 is dividing the entire side, and there were 2 terms on that side, so each term gets divided by 2. This negative 6x divided by 2 will be a negative 3x. Y is by itself, alone and positive on one side. This is solved for y. Notice that we didn't get a solution in this case because we don't have a value for x. So the result of solving for y means that I still have an equation. The other side has a variable in it, but I can't go any further. The project was simply just to get y by itself on one side. Let's have one more example. In this case, we have a familiar formula from physics, F equals ma. Force is equal to mass times acceleration. This is all variables. It's also already solved for F. F is alone and positive one side. And this form of this equation is very useful. But we could also solve it for other variables. I could choose m, which represents mass, and solve this equation for m. If I want to get m by itself, I need to undo multiplying by a. So I'm going to do the inverse to both sides. I'm going to divide both sides by a. When I do, they'll cancel out, leaving n by itself on this side. We're used to seeing the variable that's solved for on the left. So I'm going to switch the positions of these sides and get the result m is equal to F divided by a. Mass is equal to force divided by acceleration. So this is the same formula, but it's solved for a different variable. Just like in this example, these are the same equations. It's just written and organized in a different manner. It's very often helpful to solve equations for one of their variables.